Hello, everyone. In this lesson, I wish to derive the derivative for ArcSine. And first of all, we assume that y equals to ArcSine. Okay, ArcSine can be written in two different forms. It used to be ArcSine like this. Now it's more popularly written as ArcSine like this. The domain of ArcSine is from -1 to +1. Excuse me, the range is between negative pi over 2 to positive pi over 2, which means that by definition of arcsine and sine function, that domain from -1 to +1, right? The range, meaning, y is going to be an angle. X is ratio, y is angle. This angle either terminates in the first quadrant or terminates in the second quadrant. And this also means that if y equals to arcsine x, and x equals to sine of y. Okay, so x equals sine of y means y is the angle. Okay, so I'm gonna just to show you, annotate. So y could be, y is between negative pi over 2 to pi over 2. That could mean that y is this angle, right? Or this other angle, if measured clockwise. Okay? Now, so the terminal cannot possibly be in quadrant 2 or quadrant 3 because the domain and range for arcsine. All right. So let's move forward. Okay, we're going to come back to this a little later. Now, from what we got, right? We actually, I'm going to redo this because I recorded earlier, and for some reason the recording didn't show up. So this is my second time recording this. But anyway, so we got y equals to arcsine x, right? And we understand that means the sine of y is equals to x. And what we want is we want dy dx. We're gonna take a derivative on both sides. Okay, so on the left-hand side, take a derivative with respect to x. On the right-hand side, we take a derivative with respect to x. The right-hand side, of course, is equal to 1. On the left-hand side, we will apply same rule, which means that we're going to have a derivative of sine of y over dy multiply dy dx. Dy dx is what we wanted, that equals to 1. And of course, sine y, the derivative of sine y is cosine y with respect to y. So cosine y equals to, multiply dy dx equals to 1. So we just copy. So for dy dx, we're getting that we divide both sides by cosine y. So we got a 1 over cosine y. And of course, this is not done, right? So we know sine y is x, right? We know sine y is x. So let's look at these two pictures again. Sine y is x, meaning, right? Sine y is x. So the angle, so let me draw the angle again. Right? So if y terminates in the first quadrant, right? So that means from here, I'm going to insert that if sine y equals to x, right? That's the information we get. It could be this terminal. It could be this terminal. Okay, either case, there are only two possible cases. And we want to find out what is the cosine y. Cosine y is, okay, is the red line, which is the adjacent sides of y divided by hypotenuse. Hypotenuse equals 1. So cosine y is equal to the length of the red. The red, I'm going to make it a different color. And what is the red equals to? The red is equals to, by Pythagorean theorem, equals to square root of 1 minus the blue squared. Then of course the blue is equals to x squared. That's if the case is, y is measured counterclockwise and terminates in the first quadrant. If it measures clockwise, which is going to terminate in the fourth quadrant, and we would have drawn the same conclusion, right? It's still the same red. They share the same red. So that's how we have derived the, the derivative of ArcSine, the derivative of ArcSine, okay? So in the end, we're going to complete this. That's going to be equals to 1 over the square root of 1 minus x squared. That is, right, the derivative of ArcSine of x is equals to 1 over square root of 1 minus x squared. Finished, okay? So let's look at the derivative of ArcCosine. Okay, for the derivative of ArcCosine, all right? So I'm going to bring back up the picture I drew. I drew. And I'm going to delete all of these. Okay. And then we're going to make a way for deriving the derivative of ArcCosine. For ArcCosine, the domain is from -1 to +1. It's a ratio, and y is angle. And the angle, because ArcCosine gave from input ratio, output angle. And the angle can only be between 0 to pi. In other words, the terminal is either terminating in the first quadrant or terminating in the second quadrant. So from this piece of information, from this assumption, right, we know y is angle, x is ratio, cosine ratio, and this implies that cosine y is equals to x. What does it mean cosine y equals to x, right? It could be one of these two cases. One of these two cases. Case 1, it could be y is measured counterclockwise, right? This could be the y. Okay, terminates in the first quadrant. Second case is y terminates in the second quadrant. So these are the only two cases for ArcCosine y, okay, for the range. Now, with this understanding, so we know the red is x, the hypotenuse is 1, right? Because the cosine y is the adjacent side over the hypotenuse, the adjacent side of the hypotenuse. That's why we mark x on the red. Hypotenuse is 1, okay? And now we're going to clean this up, and we're going to start deriving. We're going to derive we're going to take a derivative on both sides, okay? So taking derivative on both sides, with respect to x, Okay, so we take a derivative of cosine y. That equals to the derivative with respect to x on x. The latter equals to 1. So we're going to apply chain rule one more time. And on chain rule, we got derivative of cosine y, dy, multiply dy dx. And the right-hand side equals to 1. As we know that the derivative of cosine y with respect to y is going to be negative sine y, and that multiply dy dx, that equals to 1. Solve for dy dx. Wait. Hold on, sorry. To solve for, so here, copy. Okay, that will be right, okay? So we solve for dy dx here, then we got dy dx equals to 1 over sine of y, and just a negative sign in front of it. We're dividing both sides by negative sine of y, so we put a negative sign in front of it. Now the question is, if we know cosine y, can we find sine y, right? We just went over knowing cosine y equals to x. Okay. Cosine y equals to x. Okay, so let me bring back those pictures, right? So if y terminates in the first quadrant, right? We know the red is x, the 1 is the hypotenuse. Blue is sine y. So from here, right, blue is sine y, so I'm going back there. The sine of y equals to the blue. And what is the blue equals to? The blue, according to Pythagorean theorem, is 1 minus x squared. 1 minus x squared. Okay? Now, what if it terminates in the second quadrant? If it terminates in the second quadrant, this will be the y, right? And the x is a negative. But regardless, the blue is still above x-axis. The blue is still positive. So the blue is still the square root of 1 minus x squared. So in either cases, right? So we will get sine of y equals to square root of 1 minus x squared. So if we plug in here, we will get negative 1 over square root of 1 minus x squared. Okay, so that is done on the derivative of ArcCosine. So next, we're going to look at the derivative of ArcTangent. Derivative of ArcTangent, as I said earlier, this is I derived it and made to make another recording, and it didn't show up. So I'm going to redo this all over again for you. Now, so for ArcTangent, ArcTangent's domain is all real numbers. In other words, the ratio can be any real number. The range, which is y as angle, is between negative pi over 2 to pi over 2 exclusive. Exclusive meaning doesn't include negative pi over 2. It doesn't include pi over 2 either. And once again, we want to find the derivative of arctangent. Okay, the derivative of arctangent, we start by assuming y is equal to arctangent. Okay, we can just use one of the forms. And this implies that tangent of y is equals to x. Tangent of y equals to x means what? It means in either one of this picture, right? is x over 1. And of course, this x, and this is the opposite side over the adjacent side. So the opposite side, blue, is x. The adjacent side, the red, equals to 1. It could also be that, the angle could be, right? It could be this angle, right? It could also be the other angle, but it cannot be any angle terminates in quadrant 2 or quadrant 3. That's the nature of arctangent, right? So that's why we cross out those other 2 quadrants. So if this is the y, or this is the y, right? So these are the only 2 cases. One, we say tangent y equals to x, which is x over 1, which is the same as x over 1. That means the blue, the opposite over the adjacent side, the red, so x1 or x1 like that. So in either case, okay, the hypotenuse, I'm going to write it down here. Okay, the hypotenuse means the black line on either picture. The hypotenuse, I'm going to use HYP, meaning it's shorthand for hypotenuse, is going to be the square root of 1 plus x squared. So we know the hypotenuse here. With these information, we're going to start taking derivative. Okay, so we start to differentiate. Let me clean this up a little bit. Okay, so we're going to differentiate on this relationship, meaning we're going to take a derivative on both sides of this equation. So dy tangent y is equals to the derivative with respect to x, dx, okay, remove that, and that equals to 1. After that, right, chain rule, and once again, the derivative with respect to tangent y, with respect to dy, multiply dy dx, and that's going to equals to 1. Derivative of tangent y with respect to y is secant squared. Okay, secant square of y. And that is multiplying dy dx and equals to 1. Now, solving for dy dx, we got 1 over secant square of x. We know that secant x is reciprocal of cosine. So this is going to be cosine square of x. Oh, sorry, it's y. Okay, secant square of y. So that's a cosine square of y. Okay, so now, what is a cosine y? We know tangent y equals to x, right? So we just drew the picture. What is a cosine y? Cosine y is for, let me mark the angle. Okay, this is y. Okay, so cosine of y is equals to the adjacent sides over the hypotenuse. The adjacent size is 1, which is red, right? Which is red. And the hypotenuse, HYP, which we just defined earlier. This will lead us, the red equals to 1, hypotenuse equals to this guy, okay, the square root of 1 plus x squared. And of course, all of these need to be squared, right? Because the cosine y squared, and this is going to be squared. And so in the end, we got 1 over 1 plus x squared. And that is the derivative. That is the derivative of ArcTangent. Okay, so that's all we're going to cover. These are mostly commonly used. ArcSine, ArcCosine, ArcTangent, the derivative of these functions we have just derived. Thank you for watching. And hold on, that was the case. If y is, if y is the other case, right? If y is the other one, same thing. Okay, so end up with the same formula. So we're done. Okay, and thank you for watching. Goodbye.